So if this is a core of a transformer, so here we can say it is a E1 induced EMF in the primary side coil. This is the induced EMF in the secondary side coil E2. Okay. If it is a N1 number of turn and it has a N2 number of turn, let me write it outside. If this is a N1 number of turn, this is a N2 number of turn, then so due to some supply, uh, current is flowing through it, and due to that some magnetic flux is induced in the primary side coil, and that flux linked with the secondary side coil, and due to that E2 is induced. And when E2 is induced, then if the secondary side is closed, that is it is loaded condition, then when E2 is induced, so E2 is induced due to the mutual inductance, and E1 is induced due to the self inductance. Here you put some input, that is some generator. You put some generator over here which is capable to generate some current. আর কাউকে admit করব না. Okay, so that when due to the generator, if this is, you can consider EG, that is the E generated voltage. Okay, so if this is the EG generated voltage, due to that some current IP is flowing through the transformer primary side, and for that some flux, when a coil, we apply some voltage in a coil, then there is some not voltage, when the current is passed through a coil, then some voltage is induced inside the coil, that is the E1, that is this E1 is due to the self inductance. And when E1 is induced, then that for that E1 some flux is set up, and that flux is linked with the secondary side coil through the core of the transformer. When the flux is induced or linked with the secondary side coil, then obviously there must be some induced EMF, and that induced EMF E2 is nothing but due to the mutual inductance. So E2 is due to the mutual inductance, and E1 is due to the self inductance, and for that I1 current is flowing, not I1, this is I secondary current is flowing. When it can flow, it can capable of flow if the secondary side has some load, that is the short circuited. So when IS is flowing, then and as the E2 is induced, due to that another flux is flow through the core of the transformer, and if this is the red dotted line is being flux due to the self inductance phi 1, and the green color dotted line is phi 2 due to the E2, then the net flux, that is the phi m, is become phi 1 minus phi 2, or phi 2 minus phi 1, you can take it inside the mod. Okay, so basically what happened, basically one flux, that is the resultant flux, is flowing through the core. Okay, so this is the phi m, that is the mutual flux is flowing through the core, or you can say it as main flux. So which one is greater, phi 1 or phi 2, depending upon the number of turns in the coil. If the number of turns in the secondary side is more, then phi 2, that is the mutual flux developed at the secondary side, will be much more higher than the phi 1, that is the flux which is induced in the primary side. So here this is the mutual flux phi m which is flow through the core. You know everyone, but there is some another flux which is the leakage flux, which is flow through the air. Here is the leakage flux. We can say it as phi sigma 1, which is not linked with the secondary side coil, which is a lossy component, and like that there is also a secondary side leakage flux that is flow in the air, that is called the phi sigma 2. Okay, that flux, that phi, that fly, they are capable of induced some EMF, but they are not linked with each other. That is the phi sigma 1, if linked with somebody, then it can capable of produce some EMF. Likewise, if phi sigma 2 is linked with some coil, then it can also capable of induce some EMF for it. বুঝতে পারছিস? যদি এই phi sigma 1 টা যদি অন্য কোনো কয়েলের সঙ্গে লিঙ্কড হতো, তাহলে কি সে কিন্তু it can capable of producing some EMF. কারণ কি this is due to the Faraday's laws of electromagnetics. If there is a phi and if you put one coil inside it, so some current will flow through the conductor, that is the Ampere's law, and if there is a phi, then there is some induced EMF inside the coil, that is the Faraday's laws of electromagnetics. So phi sigma 1 and phi sigma 2 are producing in the primary side and secondary side, and they cannot link through the core to each other. That's why they are the lossy component, that is the lossy magnetizing component. So so how many flux we have? We have 3 flux. Okay, what is the ampere turns? Ampere turns in the primary side is N1 into I1. If I1 is flowing through it, you can say it I1, you can say it as I2. So N1 I1 is the ampere turns in the primary side. So that is due to two component. One is phi m1, that is the red color, phi m1, and obviously phi sigma 1. Okay, likewise I2 into N2 has two component. One is phi m2 and phi sigma 2. What is phi m1? Phi m1 is that red dotted line. What is phi m2? That is the green dotted line. But we are not considering this phi m1 and phi m2, because phi m is the resultant of this phi m1 minus phi m2, and as they are flowing in the opposite side, that's why you can make them subtract one to other. Okay, so phi m is what? It is a mutual flux. Phi m is the mutual flux. Now, so we have 3 fluxes. One is primary leakage flux, that is the phi sigma 1, that is leakage component that cannot establish any EMF, extra EMF. It is induced in the primary side, that is it is associated with the U1. Second one is the secondary leakage flux, that is the phi sigma 2, and third one is the mutual flux. কোনো বইয়ে দেওয়া আছে main flux, but টেকনিক্যাল টার্ম হচ্ছে মিউচুয়াল ফ্লাক্স, দ্যাট ইজ দ্য phi m, that is the resultant of the phi sigma 1 and phi sigma, sorry phi, that is the resultant of the phi m1 and the phi m2. বুঝতে পেরেছিস? So now if you look into the primary and secondary induced voltage, now look into the primary and secondary induced voltage. What are they? What are they? First one is E2. If you consider the secondary side, E2 is composed of two component. What are they? What are they? That is the due to the phi m and the phi sigma 2. Here phi m is the main flux or mutual flux which is linked both the primary side and secondary side, and as the this phi m is linked with the primary and secondary side, so phi m is the main cause of induced EMF in the primary side and secondary side. So phi m is common for both primary and secondary side. But in secondary side there is also another flux which is linked only with the secondary side. It cannot link with the primary side. That one is the phi sigma 2. Phi sigma 2 is linked in the secondary side winding, but it cannot go to the primary side. It doesn't have any effect to the primary side. It has only effect in the secondary side. But due to this flux, there is also some portion of induced EMF is there in the secondary side, na? ये फाइव सिग्मा टू यहाँ पे बन रहा है, जो फाइव सिग्मा वन जो प्राइमरी वाइंडिंग से जिसका कोई मतलब नहीं है, लेकिन ये जो फाइव सिग्मा टू बन रहा है लीकेज फ्लक्स, वो कुछ अमाउंट ऑफ थोड़ा बहुत अमाउंट ऑफ तो ईएमएफ इंड्यूस्ड करेगा, जो ईएमएफ इस मेन फ्लक्स का ईएमएफ से जुड़ के हमको ई टू मिल रहा है. डिड यू गॉट माई पॉइंट? आया समझ में क्या बोले हम? Did you got my point? Any confusion? Hello?
No, sir.
Okay. So, the voltage due to the mutual flux, the voltage due to mutual flux phi m क्या होगा? इज इक्वल टू क्या होगा? ई m2, ये क्या हो सकता है? 4.44 इंटू N2 इंटू F इंटू phi m. This is the EMF equation of the transformer. The voltage due to the leakage flux, not here you cannot write the mutual flux, the leakage flux, phi sigma 1 is, if you write it as E sigma 2, it becomes 4.44 into N2 into F into phi sigma 2. यही होगा ना? यही होगा तो? These two are the flux induced in the, this is the EMF induced in the primary and secondary side, and likewise you can say, that for in the primary side, two components which is producing, which R होगा ये, components है मतलब R, which are producing E1, क्या होगा, EM1 क्या होगा, 4.44 into N1 F into phi m, and E sigma 2 क्या होगा, 4.44 into N1 into F into phi सिग्मा 1, ये सिग्मा 1 होगा, 2 नहीं होगा, सिग्मा 1 होगा, ठीक है। यही दोनों है जो E1 और E2 को बना रहा है, ठीक है। इज देयर एनी डाउट?
नो सर।
So the main thing is E1 is the vector sum of EM1 and E sigma 1, and E2 is the vector sum of EM2 and E sigma 2. EM2 or E sigma 2, if we add them, how can we add them? We add them vectorially. Here, that's why we have to draw a phasor diagram to get the E1 and E2. Whatever the flux is R, that is the phi m and phi sigma 1 or phi m and phi sigma 2, they may or may not be in the same phase. They may or may not be are in the same phase. If they are in same phase, then they are in the same line. There is no phase angle between them. If they are not in same phase, then they have some phase angle between them. So that is the non-idealities which we can consider when we consider in a when we draw the phasor diagram. So now if you try to draw the phasor diagram, so not phasor diagram, that is the equivalent circuit. First you draw the equivalent circuit. So this is the core of the transformer. Core of the transformer. Here the primary winding is there. Okay. So so, and this is the secondary winding. The secondary winding. So here EM1, this EM1 is produced due to phi m, and EM2 is also produced by phi m, but E sigma 1 is produced by phi sigma 1 and E sigma 2 is produced by phi sigma 2. वही है ना, जो लीकेज रिएक्टेंस होगा वही तो E sigma 1 and E sigma 2 प्रोड्यूस करेगा. So here if you consider the circuit here, if EM1 is produced in the primary winding, this is due to what? This is due to the main flux phi m, the main flux phi m which is producing the EM1. Is there any confusion? The main flux produces the EMF EM1. Now what is about the E sigma 1 that is produced by the sigma into 5 sigma 5 sigma 1? There is another flux 5 sigma 1 which is a leakage flux, which is also producing some EMF, that is the E sigma 1. Where should we keep the E sigma 1? You can keep the E sigma 1 over here. You can keep the E sigma 1 over here. If this is n1 number of turn, so this is also an n1 number of turn. If these two have the same number of turn, and then you can say that E sigma 1 which is flowing, which is generated but cannot link through the core, that is, it is a leakage reactance, and due to that leakage reactance the flux which is generated due to it, that is the leakage flux, which is not associated with the transformer core, that cannot mix up in the air. So you just detach that part from the core. Here this is a leakage flux phi sigma 1, and due to that here E sigma 1 is produced. Now EM1 plus E sigma 1, you can say that this point is nothing but the E1. E1 is nothing but that in this two terminal E1 is produced, which is a vector sum of E sigma 1 and the EM1. You got my point? You got my point? यहाँ पे जो N1 टर्न है उसका अंदर जो फाई एम है जो कोर का अंदर से रिलिंक कर रहा है सेकेंडरी से, वो तो हम अलग कर दिए, लेकिन इसमें जो एयर लॉस है, मतलब जो तुम्हारा जो रिएक्टेंस है जो तुम्हारा कोर से लिंक नहीं हो पा रहा है, वो क्या हो रहा है, एयर में जा रहा है, एयर लॉस हो जा रहा है. उसको हम क्या कर रहे हैं, वो हम we are detaching that part from the transformer core, and in the same number of turn we draw in the air. That is, we can say that this part is a lossy part that is not associated in the core. So this is the phi sigma 1. So like this, in the secondary side phi m is flowing, that is phi m, that is the main flux or the mutual flux, is linked with the secondary side which has a n2 number of turn. So due to that here the induced EMF is EM2, that is the induced EMF due to the main flux. Now if you draw the secondary side, obviously there is a n2 number of turn, and in that n2 number of turn here E, if this is a n2 number of turn, and due to that if the leakage reactance is phi sigma 2, then due to that the induced EMF over n2 turn is E sigma 2, which is not linked with the core, which is go outside in the air. This is the equivalent circuit. Now another non-idealities we have to consider, that is the core, not core, the winding, the primary side winding and the secondary side winding, both have some finite resistances. So whatever the core, the winding is made up of, it may be made up of the aluminum or it may be made up of the copper. So there must be some resistances associated with the wire, so that resistances can be drawn over here like it. This is the, you can say that R1, the R1 is the resistance in the primary side winding. Likewise this is the R2, which is the resistance of the secondary side winding. Did you got my point? Now for if you say this is and the secondary side terminal, so this is the E2 is the induced EMF, that is the generated EMF from the secondary side, and this E2 is nothing but the summation of E sigma 2 and EM2. Likewise this is the primary side E1, which is nothing but the summation of vector sum of the E sigma 1 and EM1. Now you complete the diagram like this. So what we did, we just, this is the EG. So here you can say this is the secondary side winding and we put some load in the secondary side. Okay, so here this is the Z2 secondary side load. Here it is the EG. EG is the generated voltage, that is which we are applying in the primary side. Due to that E1 is induced. E1 is nothing but have the two component. One is the leakage reactance, the EMF, induced EMF due to the leakage reactance, that is the E sigma 1, and another is the EM1, which is due to the main flux of the mutual flux. Like this EM2 and E sigma 2 are the secondary side, the induced EMF due to the main flux of the mutual flux and the leakage reactance. Okay. Now you see that this is the lossy part, na? This is the lossy part. We are just take it out, the lossy part we can take it out from the core component. So when a transformer core having no loss, then we can say that that is a ideal transformer. So you can say this is the circuit, equivalent circuit of this part is the equivalent circuit of a ideal transformer, where no loss is there, only phi m is flowing through the circuit, through the core, and due to that EM1 or EM2 is generated, there is no loss associated. But if there is some loss, which is the leakage reactance, the loss due to the leakage reactance, then we should draw this transformer like this. Okay, so we can say that practical transformer is nothing but the equivalent circuit of ideal transformer as well as some non-idealities, not only the leakage reactance, there are other non-idealities which is associated with the transformer. Okay, so we have drawn the winding resistances and we have drawn the leakage reactance equivalent circuit. Now we are going to draw the entire transformer equivalent circuit. কেউ বুঝতে অসুবিধা হচ্ছে? কারো বুঝতে অসুবিধা হচ্ছে? না স্যার। সো কতটা পর্যন্ত এঁকেছিলাম? This is the generated EG, no problem. Here we can say this is the R1, that is, what is the R1? We will explain in the last. This is the reactance, leakage reactance. So here this is the primary side, this is the primary side winding. This is what? This is the primary side winding, because this part I am going to draw the entire circuit, then you will understand what is the difference between the primary side, the practical transformer and the ideal transformer. So now the secondary side is like this. Same way we can draw the secondary side transformer circuit. Here you can draw the leakage reactance in the secondary side. This is the resistance of the secondary side winding. Okay, so you can make it open circuit. So this part is what? This is the induced EMF, that is the EM1. This is the induced EMF in the secondary side, EM2. This is what? This is the E sigma 1. And if you write, if you represent this coil, that is a inductor that can be, that has some reactance, that is denoted by X sigma 1, that is the leakage reactance in the primary side. X sigma 1 is what? X sigma 1 is the leakage reactance in P, that is the primary side. Okay, like this is the X sigma 2. X sigma 2 is the leakage reactance in secondary. This is the R1. R1 is nothing but the resistance of coil in primary. This is the R2. There is the resistance of coil in secondary. These are the non-idealities, but here, due to this, if I1 current is flowing through it, then there is some voltage drop across it, that is the I1 R1 is the voltage drop across the primary winding, that is the I1 square R loss. There is some the copper loss na, which is, that is some the winding loss na in the primary side and secondary side of the transformer. Likewise, if you short make this circuit short, then there is some secondary side current which is flowing through the secondary side, it can be considered as I2. So for that, I2R2 I2R2 is the voltage drop across R2. So in the X sigma 1, that is the secondary side leakage reactance, the induced EMF is E sigma 2. Okay. Now this is the two terminal. Here this is the EG, generated voltage, and here it is the E1, induced voltage. E1 is, now this plus this plus this give you the E1, is it? And this plus this will give you the EM2, not EM2, sorry, E1. Here it is the E1. So this plus this minus this, or this plus this minus this, whatever the direction is, depending upon the direction, you can vectorally sum this X sigma 1, that is the voltage drop across the X sigma 1, the voltage drop across the R2, and the induced EMF in the secondary side coil. That is, you can vectorally sum that 3 or 4 component, and then you can get the E2. This becomes E2. Now, What are the other non-idealities? The other non-idealities are the these two are the other non-idealities. This is the R L, this is the XM. What is the RL and XM? XM is the magnetizing component. What is the RL? That is the core loss component. From where they come? From where they come? From where these two XM and RL come? These two are nothing but the equivalent circuit of the transformer core, because the core is also made up of CRGO of some ferromagnetic material that has some finite resistances, and that finite resistance, that is the, if there is some finite resistance and if phi is flowing through the through that core, then there must be some eddy current loss, some hysteresis loss is there. Okay, some hysteresis loss is there. You got my point? This is the transformer equivalent core circuit, because the core is magnetized. The core is magnetized by the current, you can say Im, that is the magnetizing component current, and some current is flowing through the, due to the eddy current, that is the IE. And if the total current is I naught over here, so I naught is nothing but Im plus IE. Okay, and I1 minus I naught is the current flowing through the primary, that is the IP. You can say it IP. I1 is flowing through it, is supplied by the generator. I1 I naught is flowing through the core, that has two parts. One is magnetizing component, another is core loss component. Which part is magnetized the core? The sine part is magnetizing the core. I have already in the AC, I have already discussed that the sine part is used for the, to magnetize any magnetizing component, that is the AC, refrigerator, all these can start up, all the, or the generator, the motor, all the, if there is a coil, then you should need some magnetizing current which can magnetize the system. So Im is the magnetizing part of the current which magnetize the core. If core is not magnetized, then it is not possible to set up the mutual flux in the secondary side. And IE is the core loss, IC, not this is CE, this is C. IC is the core loss component which is flowing inside the core, and as the core has some finite resistance, then there should be some losses, that is the I is IC square RC loss is there in the core, and to prevent it we can varnish the core, we can slice the core, or we can laminate the core to minimize the eddy current. You have already studied this. So this is the circuit diagram for the core, and this is why this equivalent circuit of the core is drawn in the, with the series, with the parallel of this part. Did you have any idea? Did you have any idea why this is drawn like this? You can make this the circuit, make the these two in the series with R1 and X sigma 1. It is because whatever the secondary side is, सेकेंडरी साइड में I2 हो या ना हो, if primary side you are applying some voltage, then obviously there must be some induced EMF inside the primary side, and if there is some primary side induced EMF, that will create one phi flux. That phi flux is flow through the primary side, through the core, and if some flux is flow through the core, that can produce some eddy current, that eddy current some produce some losses, and if the flux is flow through the transformer core, then that must be magnetized the transformer. So if I2 is 0, if this is no load condition, if I2 is 0, then also I1 may be 0. If I1 is 0, then is there any flux set up in the transformer core? No. But if the secondary side is 0, till there is some flux which is produced in the primary side, and due to that some current is induced, that, and obviously if the flux is induced, that flux will link up with the secondary side, and for that if the secondary side is short circuit, then you get some current, otherwise not. But we cannot make this I not, we cannot make this part as 0, because whatever the current is induced in the secondary side or not, there must be some uh, core loss, and some magnetizing component loss is there inside the core if you put some EG in the primary side. That's why এটা যদি আমি সিরিজে আঁকি, if we put this in series, then if I1 is 0, then this whole thing is 0, that is there is no existence of the transformer's equivalent circuit. So now if you consider this entire diagram, so this part represents only the ideal transformer, this part is nothing but the ideal transformer, and this part is the equivalent circuit for the primary side winding. This part is the equivalent circuit for the secondary side winding, and this part is used, we draw for the entire core of the circuit. So this is the total equivalent circuit diagram of a transformer, practical transformer. So the practical transformer is a composed of ideal transformer and some non ideality. বুঝতে পেরেছিস? Did you have any question? Did you have any question? কারো কোনো কনফিউশন আছে? ওকে, তাহলে আজকে এই পর্যন্ত থাক। নেক্সট দিন যে ক্লাসটা নেব সবাই অ্যাটেন্ড করবি। আমি নেক্সট দিন যে ক্লাসটা নেব সেটা হচ্ছে ট্রান্সফরমারের ইকুইভ্যালেন্ট সার্কিটের ফেজার ডায়াগ্রাম। বিরাট বড় ফেজার ডায়াগ্রামে ভালো করে মাথা ঠান্ডা করে শুনবি, ঠিক আছে?